Hello everyone, this is Dharamvir sir here. So today we are going to continue with chapter 1 of grade 11 maths, that is sets. Okay, and in today's video we are going to learn about Venn diagrams, what are Venn diagrams, and the different operations on sets. Okay, so let's start. So first let me tell you what is Venn diagram. So Venn diagram is nothing, it's just diagrammatic representation of relation between sets. How to show relation between different types of sets through diagram. That is called Venn diagram. As you can see in the figure, we have written n, then w, that is whole number, then z, that is integer. Now the set of natural number is a subset of whole numbers. So n is written inside w to show that n, all the elements of n belongs to whole number. Now w is written inside all the elements of z because whole numbers is a subset of z. Now since all the elements of natural number and w, that is whole number, belongs to z, so z contains all the elements of n and w, so z acts as the universal set. Okay, and in Venn diagram the universal set is represented by a rectangle. That is why the set z is denoted by rectangle. Clear? So Venn diagram is nothing, it is just the diagrammatic representation of relation between different sets. Clear? So pause and note down the points. So next we have operations on sets. So like mathematical operation, addition, subtraction between numbers, same we have operations on sets. So let's begin with union of sets. Now the union of two sets A and B is another set C, which consists all the elements which are present in A or B. Okay, which are present in A or B. That is, set C will be equal to A union B, which is equal to X such that X belongs to A or X belongs to B. Clear? Now I have noted down few properties of unions. That is, A union B is equal to B union A, commutative property. Then A union B union C will be equal to A union B union C, that is associative property. Now A union phi, if you take the union of any set with empty set, it is the set A itself. Then A union A will be equal to what? The set A itself. If you take the union of universal set and any set A, that is U union A, then it will be the set U, that is the universal set. Clear? So pause and note down the points. Next we have intersection of sets. So the intersection of two sets A and B is another set which consists all those elements which belongs to both A and B, that is the common elements of A and B. Clear? So intersection means common elements of the sets, and symbolically it is written as A intersection B equals to X such that X belongs to A and X belongs to B. And means intersection, or means union, remember that. So few properties of intersection, that is A intersection B is equal to B intersection A, commutative property. Then A intersection B intersection C will be equal to A intersection of B intersection C, that is associative property. So and third is phi intersection A is equal to phi. Okay, then universal set U intersection A is equal to A, then A intersection A is equal to A intersection B union C distributive will be equal to A intersection B union A intersection C, and sixth is A union B intersection C, which is equal to A union B intersection A union C. So these two are our distributive properties. Clear? So pause and note down the points. Next we have difference of sets. The difference of sets A and B denoted by A minus B. If I am saying A and B, then A minus B, and if I am saying B and A, then it means B minus A. So A minus B is defined as the set of elements which belong to A but not in B. Clear? If A minus B means what? Elements of A but not in B. So we write A minus B equals to X such that X belongs to A but X does not belongs to B. and B minus A will be equal to X such that X belongs to B and X does not belong to A. As simple as that. So pause and note down the points. So let's start with exercise 1.4. So find the union of each of the following pairs of sets. Question 1. So there are so many parts. I have solved the first, third and fifth. First is we have x equals to 1, 3, 5 and set y is equal to 1, 2, 3. So union of x and y is equal to what? All the elements of x and y. We don't include the common ones. Okay, we don't repeat the elements. So x and y is equal to what? The union of set 1, 3, 5 and set 1, 2, 3. So the elements will be 1, 2, 3 and 5. We need all the elements. Just write all the elements of x and y, but don't repeat the elements. Clear? Third is we have a set A equals to x such that x is a natural number and multiple of 3. Natural number and multiple of 3. And set B is x is a natural number less than 6. Now A, the natural number multiple of 3 is equal to what? 3, 6, 9, 12, 15 up to infinite. So dot dot dot. And B is what? X such that x is a natural number less than 6. So the natural number less than 6 are 1, 2, 3, 4 and 5. So we need to find the union. So union equals to what? 3, 6, 9, 12 dot 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 union of 1, 2, 3, 4, 5. So the set will include 1, 2, 3, 4, 5. After that we have 6, 9, 12, 15 and so on. So in the set builder form we can write it as x such that x is equal to 1, 2, 4, 5 or a multiple of 3. Clear? Okay. Fifth is the set A 1, 2, 3 and set B equals to 5. Now A union 5 is equal to what? The set A itself. So the union of 1, 2, 3 and 5 will be equal to the set 1, 2, 3 will be itself. I have given this in the property also. I hope I am clear. So pause and solve the other sums. Next is question 2. Let A is equal to set AB and B is equal to set ABC. So question is A a subset of B? And what is A union B? Now all the elements of A are in B. Yes, therefore A is a subset of B. Now second we have to find the union. So A union B is equal to what? All the elements of A and B, and we don't repeat the elements. So it will be ABC. So here we get a very good property that if A is a subset of B, then A union B will be equal to B. Remember this point. Okay. So moving to question 3. If A and B are two sets such that A is subset of B, then what is A union B? Now it is same like the previous one. So we have A union B equals to what? X such that X belongs to A or X belongs to B. Okay, and now since it is given that A is subset of B, so it simply means that X belongs to B. Clear? If X belongs to A, it means X belongs to B also, if A is subset of B. Therefore A union B becomes what? B only. You can solve this by taking examples. Take the example of set A and B, then prove. Clear? So pause and note down the solution. Next is question 4. If A is set A is 1, 2, 3, 4, B is set 3, 4, 5, 6, C is set 5, 6, 7, 8 and D is set 7, 8, 9, 10. We need to find all this. So I have solved few parts for you. First is A union B. Now A union B means what? The set of all the elements of A and B without repetition. So we will get set 1, 2, 3, 4, 5, 6. Then second one is A union C. So the set of A and C. So it will be union of 1, 2, 3, 4 and union 5, 6, 7, 8. So take all the elements without any repetition. So this will be equal to what? The set 1, 2, 3, 4, 5, 6, 7, 8. Clear? Then I have solved the fifth part for you. We have to find A union B union C. Now while explaining the properties, I have told you this property, they follow the associative property. So taking A union B together, and after that we will take union C. So A union B is equal to what? We have found that it is 1, 2, 3, 4, 5. And we will take its union with C. C is equal to 5, 6, 7, 8. So write all the elements without any repetition. So this will be equal to what? 1, 2, 3, 4, 5, 6, 7, 8. Done. And sixth is same. We have to find A union B union D. So same like we did the fifth sum. We have A union B union D. So following associative property, we can write A union B. Then after we will take union D. So A union B is equal to what? 1, 2, 3, 4, 5, 6. and then we have to take the union of D. D is 7, 8, 9, 10. So write all the elements without repetition. So we will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 set. Clear? So pause and solve the other parts. Moving to question 5. Find the intersection of each pair of sets of question 1. Intersection means common elements. So X intersection Y means intersection of the set 1, 3, 5 and 1, 2, 3. So here the common elements are 1 and 3. So intersection will be equal to the set 1, 3. Set A is what? 3, 6, 9, 12 and so on. And set B is equal to 1, 2, 3, 4, 5. So intersection will be the common element. So A intersection B will be the common. What is the common element in both the sets? 3. So it will be equal to what? Set 3. Fifth, we have A intersection B. That is 1, 2, 3 intersection 5. So there is no common element. No common element is equal to 5. And while explaining the properties, I have told you that A intersection 5 is equals to 5. Clear? So pause and solve the other parts. Moving to question 6. If set A is equal to 3, 5, 7, 9, 11 and set B is equal to 7, 9, 11, 13, set C is equal to 11, 13, 15 and set D is equal to 15, 17, we have to find. I have solved first, that is A intersection B. So intersection means only common elements. So the common element in the set A and B is equal to what? 7 is there, 9 is there, 11 is there. So 13 is there. No, 11 is there. So it will be equal to the set 7, 9, 11. Then B intersection C. So common in B and C is what? Only the elements 11 and 13. Then A intersection C. So the common elements in A and C will be equal to what? Set 11. Then B and D. So we have to take the common in B and D. Now write as shown in the video. You have to write like that. A intersection D is equal to, you have to take set 3, 5, 7, 9, 11. Intersection the set D. D is equal to 15, 17. Then write the common element. What is common in A and D? Nothing. Nothing means what? No element. That is 5. Then I have solved 8th part. That is A intersection B union D. So A is 3, 5, 7, 9, 11. Intersection of B union D. So first find B union D, which will be equal to 7, 9, 11, 13, 15, 17. Now check what is common. So we can simply see that the common elements are 7, 9, 11. So A intersection B union D is equal to what? The set 7, 9 and 11. Clear? So pause and solve the other parts. Next we have question number 7. If A equals to X such that X is a natural number, B is equal to X such that X is an even natural number, and C is equal to X such that X is an odd natural number, okay, and D is equal to X such that X is a prime number, then we have to find these. So first is A intersection B. A intersection B is equal to what? B. Why? Because B is subset of A. B is what? X is an even natural number and A is natural number. So all the elements of B are in A. So the common will be what? The elements of B. Clear? So A intersection B is equal to what? B. Third is A intersection D. Now A intersection D is equal to D. Why? Because D is again a subset of A. D is what? A prime number. And all the prime numbers are included in natural numbers. So all the D are in A. So D is a subset of A. So A intersection D becomes D. Then we have to find B intersection D. B intersection D. Now B is an even natural number. D is the prime number. So what will be common? Only one element is common. 2. 2 is even and 2 is prime. So B intersection D is equal to what? 2. Then C intersection D. C is odd natural number and D is prime number. So C intersection D becomes what? X such that X is an odd prime number. Odd and prime number. Clear? So pause and note down the solution and solve the other parts. Moving to question 8. Which of the following pairs of sets are disjoint? Okay, I think I forgot to explain disjoint. Disjoint means two sets are said to be disjoint if their intersection is empty. That is, A intersection B is empty, then we'll say that A and B are disjoint. That nothing is common between those two sets. Clear? So we have first, that is 1, 2, 3, 4 and X such that X is a natural number and 4 less or equal to X less or equal to 6. So A is equal to 1, 2, 3, 4. The second set will be what? 4, 5, 6. Now is there anything common between these two? Yes, 4. So A intersection B becomes what? The set 4, which is not equal to 5, therefore they are not disjoint. Clear? Second is we have A, E, I, O, U, and second is C, D, E, F. Now we can simply see that the element E is common in the two sets. So since it is they have a common element, so they are not disjoint. Third, X is an even integer and X is an odd integer. X is an even integer and X is an odd. So there is nothing common between even and odd. Okay, and since there is nothing common, so these two sets will be disjoint. If something is common, then not disjoint. If there is no common, then it will be disjoint sets. Clear? So pause and note down the points. Next we have question number 9. We have set A 3, 6, 9, 12, 15, 18, 21. B equals to 4, 8, 12, 16, 20. C is equal to 2, 4, 6, 8, 10, 12, 14, 16, and D is equal to 5, 10, 15 and 20. We have to find, I think all this are minus the difference. So A minus B. So A minus B means all the elements of A which are not in B. So not in B but in A. So we can see that 3, 6, 9, 15, 18, 20. 1. These are in set A but they are not in set B. Okay. Okay. Same is A minus C. So we have to check the numbers which are in the set A but not in C. Simply we can see that 3, 9, 15, 18, 21 are in A but not in C. D minus A, same, the elements in D but not in A. D but not in A. So we have 5, 10 and 20. They are in D but not in A. Clear? Then we have B minus C. So again elements which are in B but not in C. So only one element is there, that is 20. Then D minus B. So the elements in D but not in B. So we have 5, 10 and 15. Then we have C minus D. So the elements in C but not in D. So we have 2, 4, 6, 8, 12, 14 and 16. So in the same way you can solve the other parts. Next is question number 10. If x is equal to ABCD and y is equal to FBDG, find x minus y. So x minus y means what? The elements which are in x but not in y. So we have only two elements, that is A and C. Now y minus x. So y minus x means the elements which are in y but not in x. So we have two elements again, F and G. And x intersection y means what? The common elements. So the common elements in x and y are what? B and D. Very simple. So pause and note down the solutions. Going to question 11. If R is the set of real numbers and Q is the set of rationals, then what is R minus Q? Now R is the set of real numbers, and real numbers include all the rational numbers and all the irrational numbers. So from R minus Q we conclude what? If we subtract all the rational numbers, we'll be left with what? Irrational numbers. Okay, so R minus Q will be equal to what? T. T is the set of all the irrational numbers. Clear? So pause and note down the solution. Going to question 12. State whether each of the following statements is true or false. You have to justify your answer. Now first is 2, 3, 4, 5 and 3, 6 are disjoint sets. False, because disjoint means that there should nothing be common in the sets. But here the element 3 is common. Okay, so it is not equal to 5. So not equal to 5 means it is not disjoint. It means this statement is false. Then A, E, I, O, U and A, B, C, D are disjoint. Again same, since we have a common element A there, so it will be non-disjoint. So it is false. Third, 2, 6, 10, 14 and 3, 7, 11, 15 are disjoint. Yes, because nothing is common. So their intersection will be equal to 5. So it is true. Fourth, we have 2, 6, 10 and 3, 7, 11 are disjoint. Again, since their intersection will be 5, there is no common element, so it will be disjoint. So it is true. Clear? So pause and note down the solution. With this we end exercise 1.4. So solve all the sums of this exercise and also the examples given before the exercise. Thank you and all the best.